Hello everyone, I hope you're doing well. So in this video we're going to discuss Leetcode problem of the day, and today's problem is furthest building you can reach, and it is a medium level problem. So the problem basically says that we have been given an integer array heights representing the heights of different buildings. We've also been given some bricks and some ladders. So basically let me just take you to one of the examples. So let's say we consider the pair 2, 7. This is representing two adjacent buildings. Now since the height of the next building is greater than the height of my current building, I'll have to use either bricks or ladders in order to go from my current building 2 to my next building 7. Right. Now how can I use the ladders and the bricks? If the difference between these two buildings is x, then I would need x number of bricks. Otherwise, I'll need just one ladder. No matter what the difference between the heights is, I'll always use one ladder. But if the height difference is x, I'm going to use x bricks. For example, here the height difference is going to be 5. So that means if I use bricks, in order to go from 2 to 7, I'll need to use 5 bricks. If I use a ladder, I'll use only one ladder. Now let's say the height is less. For example, from 14 I wanted to go to 12. That basically means you will not require anything and you can just directly go from 14 to 12. So you need those bricks and ladders only when the height of the next building is greater than the height of my current building. So let us see how we can solve this particular problem. Let me just take this particular thing. The output is 4 for this particular sample test case, and let us discuss this. So I believe that there will be multiple solutions to this particular problem. I solved this problem using binary search. Why did I exactly apply binary search? Let us understand that. So binary search can only be applied on a monotonic array. So it should be either monotonically increasing or it should be monotonically decreasing. Right. This is the primary condition for binary search. So increasing or decreasing does not make really sense here, but there is a property that will make a lot of sense. So let's say we are considering these as positions 0, 1, 2, 3, 4, 5, 6. So I have a very simple question. If I am able to reach position 3, will I be able to reach position 1 or not? The answer is yes. Why not? If you are able to reach position 3, then you will definitely be able to reach position 1 or not. Position 1. If you are able to reach position 3, will you be able to reach position 5 or not? This may or may not be true, right? Because I have been able to reach position 3 successfully, but I am not sure whether I'll be able to go forward or not, right? So basically what I am trying to say is, if you know that you can reach a position X, you will always know that you'll always be able to reach a position smaller than it, right? So my truth array for my current input will look something like this. So truth array is basically this position is possible, this position is possible, this position is possible, this position is possible, this is not possible, not possible, and not possible, right? So it is going to look something like this. It will be true for a couple of starting values and then it will be false, right? Now we just have to find the position of this last truth or the last position that I can reach. This is what the motive behind binary search is. Now the question is, how do I actually apply binary search? I'm going to do a binary search on the last position of this truth value. If my current value is truth, I can try looking on the right side to find another truth value. If my current value is false, I can try looking on the left side to find the last truth value. Right. Now let's say I'm at position I, that is 3 in this particular case. Let's say my mid value is equal to 3. So how do I form the checker function? This should be my next question. So for forming the checker function, first of all, let me just write the differences in the height. So from 4 to 2, I can get for free. I don't need to write it. From 2 to 7, I need 5. From 7 to 6, I can get for free. So that is not an issue. Let me just take some other values as well. So let's say my mid was here. This is 4. So from 6 to 9, I'll have to use 3 value. Right. This is my problem now. If you see it very carefully and if you solve yesterday's Leetcode problem the day, then you will realize this problem has somewhat reduced to yesterday's problem only, right? The only reason I took binary search approach was so that I can relate it to yesterday's problem, right? Now you can clearly see I've been given two values. Let us just ignore the number of ladders for now and focus only on the bricks, right? So I've been given two different values. I've been given the number of bricks, right? I can use these bricks to make these values independently 0. I can use sum of the bricks to make this value 0. I can use sum of the bricks to make this value 0. This is the exact problem that we were facing yesterday. We were given some values and we were given some frequency values as well. We needed to use the value k in order to make these values 0. Right. Now I'm going to again use this bricks value to make these values 0. And if I want to make the maximum number of the values 0, I would want to take the smaller values first. So once I have these heights difference array, I'm going to sort them and I'm going to use the bricks to make all of them 0. I can make 3 0, but I cannot make 5 0, because if I make this particular 3 0, my remaining bricks will be 2. Now I cannot use these 2 bricks to make this particular 0. Right. If I cannot complete the whole operation, or I cannot move to the next building using the bricks, that means I'll have to use some ladders. Right. So I was able to make this one 0, and that is fine. Now I have one height difference remaining and one ladder remaining. Right. So this is always possible. Right. Because I can use that ladder to make this difference 0. Now, what is the final approach? I just related it to the yesterday's problem. What is going to be the final approach? So let me write it. I am going to write the height difference and going to sort it. Right. The second step should be, so let me write it as the first step. The second step should be use the bricks to make the smaller heights 0 if the remaining height difference is less than or equal to the number of ladders, then answer is possible, otherwise it is not possible. Right. This is going to be my final approach to write my checker function. Right. So how does this work? First of all, I'm going to write the height differences between each of the individual buildings, and I'm only going to write it if the difference is positive. That means the next building is greater than my current building. Then I'm going to sort the whole array and use the bricks to make the smaller heights equal to 0. This is the best way, this is the greedy way to make use of the bricks, and this will be the way in which you will be able to make most of the building height difference equals to 0. Right. And at the end, you will be remaining with some values. You might or might not be remaining with some values, but whatever values are remaining, you can use ladders in order to make those differences 0. So if the number of differences that are remaining are less than equal to the number of ladders, that means you can form your answer, otherwise you will not be able to form your answer. Right. Why not be able to form your answer? Because even after using all the bricks and all the ladders, there will still be some height difference remaining. Right. So this was the whole approach. And if we talk about the binary search, I am going to use an invariant technique of binary search. Right. So what is this invariant technique? In this technique, I assume that one of the lows and highs, there are two values, right? One is low and the other one is high. I am going to assume one of them is always true and the other one of them is always false. So in this particular case, 0, that is the low, is always going to be true and this is always going to be false. Why? Because 0 is my starting position. I can always reach this no matter what, and I can never reach the position n because it is out of the index array indexes. Right. Now I just have, if my current mid satisfies the condition, that means my low is going to be the mid. If the current mid does not satisfy the condition, that means my high is going to be the mid. And at the end, since low is always true, my answer is going to be stored in the low, so I am just going to return low value. This is how the invariant technique works. So let me show you my solution, what I have done. So what I have done is, I have initialized the size n, which is the heights array size. Right. Now I have initialized low with 0 and high with n. This is my checker function. We'll come to it in a little while, but let us just first look at what we are going to do downwards. So while low is less than high minus 1, I am going to set my mid as low plus high minus low by 2. So this is just basically calculating the mid. If check of mid returns 2, I am going to set my low as mid, otherwise I am going to set my high as mid. At the end, I just return low for the reasons I have discussed earlier. And now if I show you my check function, I have my remaining bricks. So that is the number of initial bricks that I have, and I have initialized my vector int of need. Now I am just going through all the values till position p, right? So I need to go to p. That is why I need to make my loop less than p, because when I am at p minus 1, if I am if I push that particular height difference, then I'm going to reach position P. So if heights of I plus 1 is greater than heights of I'm just going to push it into my heights vector. Now I'm just going to sort it. I'm sorting here it in reverse order. Reason you will see in a while automatically. So what I'm doing is I've sorted all the values in reverse order, and while need dot size and remaining bricks are greater than or equals to the last element, that is need dot back, I'm going to subtract this particular need dot back from remaining bricks and just pop it back from the need vector. At the end, I'm just going to return ladders is greater than or equals to need dot size, right? So you see what happened here was, by sorting the array in reverse order, I make this implementation a little bit easier. Otherwise, I'll have to keep track of how many elements I use from the front. Then I'll have to keep track of how many elements would be remaining, right? This was this would not be difficult. It's just that it will lead to some more code writing. So that is why I just sorted it in reverse order. This looked more convenient to me, and I just made a simple for loop while need dot size. That means there are some elements in the need vector, and my remaining brick is greater than or equals to the last element, that is going to be the smallest element. I am going to subtract this value from need remaining brick and just pop it back from the vector. So basically all the smaller values are going to be popped back from a need vector, and the remaining size should be less than or equals to the number of ladders that we have, right? This is how I solved this particular problem. Let me just quickly submit this and show you that this particular code works and the solution is correct. So you see, this passes all the test cases. I hope that you guys were able to understand the solution. If you guys did, consider dropping a like on this video. Don't forget to share thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video was actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.